All right, this video is going to help us understand how to use the conic section definition of a parabola to model real-world data. Parabolas are involved in many things we do in the real world. Satellite dishes, if you've ever seen a satellite dish with this amplifier out here, again, the dish is a parabolic curve. That amplifier would be at the focus. Again, if a telescope has a parabolic mirror, again, there's always a collection device off that mirror. Again, that's always at the focus. And again, flashlights can work that same way. If ever you've turned the end of a flashlight and had that circle on the wall get either larger or smaller, it's changing where that focus is compared to where that sort of parabolic curve is. One unique unique thing to know is rays coming directly into a parabola will always reflect or deflect directly into the focus. So it's kind of a unique thing. You can use a parabola to collect information. Well, depending on what we know about our parabola can help us define how we're going to kind of set this up. So writing an equation when a vertex is at 0, 0. Remember, when we're at 0, 0, our definition of our parabola is either going to be a y squared or an x squared equal to 4p. And again, if it's y squared, it'll be 4px, and if it's x squared, it'll be 4py. And again, that depends on whether or not we want to travel horizontally or vertically. So the first thing we would want to do is draw ourselves a sketch. If I know my focus is going to be at 0, 3, and my vertex is at the origin, why not draw a picture? I've got my vertex at the origin, we got our focus above it by 3 units. Well, in that case, we also know, if our focus is above there, that our p-value is 3. And really knowing those two things is more than enough to define our entire equation. All we really need to know is that p-value and understand whether it's positive or negative and kind of how to lay this out. Because it's a vertical axis of symmetry, we're traveling upward, we know that we're going to be x squared equals y. Because p is 3, that means that 4p is 12, and our final equation would be that x squared equals 12y. And we've got it done. We can do the same thing with, we know information about the directrix. Again, the vertex at the origin is hugely helpful because all that means is all we need is that p-value then. We haven't shifted anywhere. So having a directrix at 4 means I can draw that out. That immediately tells me that, again, with my vertex at the origin, my focus will be to the left side of the origin. My parabola will be traveling to the left, which already immediately also tells me that it's a horizontal axis of symmetry. We're going to be talking about a y squared equation. Well, if it's a horizontal axis of symmetry, as we said, y squared equals x. If x equals 4, that means that the p-value should be 4 units. But remember, we travel toward the focus. That 4 units should take us to the focus. So actually our p-value will be a negative 4. Take that times 4, pop it into our equation, and we've got y squared equals negative 16x for an equation. Again, drawing that sketch is a hugely helpful and very important part at the very beginning of really laying out this equation. Don't be afraid to draw the sketch. Well, let's try that again with the information given to us here. Think about what they're telling us, draw yourself a sketch, and see if you can't come up with the equation for a parabola with this information. Alright, so I drew a quick sketch, not a very great one, but good enough, and took a look at, okay, what do I know? I know that my directrix is y equals 1, my focus is at 5, negative 3, and halfway in between those two should be our vertex. So our vertex is going to fall at 5, negative 1. Again, 2 units down from 1, 2 units up from negative 3. So we've got our vertex. Now, since that's not at the origin, we can't use our simpler equation. We're going to need to incorporate that h and k. So remember, our larger formula for a parabola opening up or down, right, opening up and down, is going to be x minus h squared equal to 4p times y minus k. Because our total distance from focus to directrix was 4, then half that distance, or the distance from the focus to the vertex, should only be 2. But again, because we're opening down, it's also a negative 2. So the only things we have left to do then is take that times 4. So 4p would be equal to negative 8. And finally, let's write that into our formula. And written into our formula, that means that x minus 5, right, our h value, squared equals negative 8, our 4p value, times y plus 1. Remember that negative 1 inside, y minus the negative 1 makes y plus 1. Let's try another model here real quick. What if they gave us this information? Find the standard form equation of the parabola. So we already kind of know what we're talking about. Either x squared or y squared equals 4px or 4py, maybe incorporating that h or k. With the vertex at the origin, well, we don't need h and k will both be 0. So again, we've got that simpler form. We're going to have a horizontal axis. That means horizontal axis of symmetry. Well, if our horizontal axis of symmetry means we're traveling left and right, I'm immediately thinking this is a y squared equals 4px equation. But now notice they didn't give me the focus or the directrix, right? And they didn't give me the well, they gave me the vertex, but yeah, without the focus and directrix, what am I supposed to do with this random point? Well, the nice part is if 4, 6 is going to be on our parabola, then x being 4 and y being 6 should make our parabola or make our equation true. So what we can do is take our point and just plug it into our equation. 6 squared equal to 4p times x, or 4, means that 36 should equal 16p, and p equals 36 over 16, or basically 9/4. And very simply, we can write our equation out then. Y squared is equal to 9/4 times 4. Now remember, we want 4p, so technically 9 equals 4p. So actually, let's go ahead and take this and make it look a little bit better here to clean it up a little bit. We're just going to put in a 9 times x. And that should be the equation that will travel through this point, 4, 6, but have a vertex at the origin. Again, if they give you a random point, plug that in for x and y, solve to find p. Let's look at that one more time. Go ahead and try with this information. Again, don't be afraid to use a sketch to try to help you set it up initially, get some details. But then with that random point, let's see if we can't find the p-value. All right, taking a look at what we've got. Again, we've got a parabola opening downward. It's going from 3, 1 downwards to 4, 0, which means that x minus 3 squared should equal 4p y minus 1. Plugging in 4, 0 for x and y. I did a little bit of solving. We came out to a negative 1/4 for p. Again, we want to have 4p though, so multiply the right by 4, multiply the left by 4, and basically your p-value, or your 4p value, should be a negative 1 in your equation. So your answer is over here at the left. I hope that helps you modeling equations. Good luck in your homework, and have a great day.